Think about tall buildings. Cities need lots of space for people to live and work. Going up is the answer. Elevators make tall buildings possible. Elevators are like vertical trains. They transport us up and down. We can build taller and taller structures. This saves space on the ground. Without elevators, imagine climbing stairs in a 100-story building. Elevators make our lives easier. Think of all the time and energy they save. Elevators are engineering marvels. Let's learn about the science behind them. An elevator system has several key parts. The car carries passengers. It moves up and down in the elevator shaft. Counterweights help balance the weight of the car. Pulleys and cables connect the car to the counterweight. The motor provides the power to move the system. Safety features are crucial. Emergency brakes stop the car in case of a malfunction. Sensors monitor the elevator's movement and position. Understanding these basic components helps us appreciate the complexity of elevators. Let's delve deeper into each part and see how they work together. Imagine lifting a heavy object. You can feel the strain in your muscles, the effort it takes to move it even an inch. It's a challenging task that requires a lot of strength and energy. It takes a lot of force, right? Your body is working hard, every muscle engaged, every sinew stretched to its limit. It's a true test of your physical capabilities. Now, imagine lifting that same object with a counterweight. Suddenly, the task becomes much easier. The counterweight helps to balance the load, reducing the amount of effort you need to exert. A counterweight is a heavy weight attached to the other end of the elevator cables. It's like a seesaw. When one side goes up, the other side goes down, creating a balance that makes movement more efficient. When the elevator car goes up, the counterweight goes down. This opposing movement helps to balance the forces, making it easier to lift the car. This balancing act reduces the amount of force needed to move the car. The counterweight takes on some of the load, making the system more efficient and less taxing on the machinery. It makes the elevator system more efficient. By reducing the amount of energy required to lift the car, the counterweight helps to save power and reduce operational costs. It also reduces wear and tear on the motor. With the counterweight sharing the load, the motor doesn't have to work as hard, which extends its lifespan and reduces maintenance needs. Counterweights typically weigh about the same as the car, plus 40 to 50% of its maximum capacity. This precise calculation ensures that the system remains balanced and operates smoothly. This ensures a smooth and balanced ride. Passengers can enjoy a comfortable journey, free from sudden jolts or stops, thanks to the carefully calibrated counterweight system. Pulleys and cables work together to lift and lower the elevator car. A pulley is a wheel with a groove for a cable to run through. The elevator cables loop over the pulley attached to the motor. One end of the cable is attached to the car. The other end is attached to the counterweight. When the motor rotates the pulley, the cables move. This raises or lowers the car. The system is always in tension. Elevator cables are made of strong steel strands woven together. They are designed to withstand enormous forces. Regular inspections ensure their safety and reliability. Section 5. Motors, powering the vertical journey. The motor is the powerhouse of the elevator system. It provides the force needed to move the car and counterweight. Most modern elevators use electric motors. They are energy efficient and reliable. The motor is connected to the pulley system. When the motor rotates, it turns the pulley. This moves the cables, which in turn raises or lowers the car. The speed of the motor determines the speed of the elevator. Elevator motors are controlled by sophisticated systems. They ensure smooth acceleration and deceleration. This provides a comfortable ride for passengers. Section 6. Safety first, emergency brakes. Safety is paramount in elevator design. Emergency brakes are a crucial safety feature. They are designed to stop the car in case of an unexpected event. Emergency brakes are typically located on the car itself. They are activated if the elevator exceeds a certain speed. This could happen if a cable breaks or the motor malfunctions. The brakes clamp onto the guide rails in the elevator shaft. This brings the car to a safe and controlled stop. Regular testing and maintenance of the emergency brake system are essential. This ensures it functions properly in case of an emergency. Section 7. Sensors, the eyes and ears of an elevator. In the world of modern vertical transportation, sensors play a crucial role. They are the unsung heroes that ensure every ride is smooth, safe, and efficient. Modern elevators are equipped with numerous sensors. These sensors are meticulously installed and calibrated to monitor and manage various aspects of the elevator's operation. These sensors act like the eyes and ears of the system. They gather critical data and relay it to the control system, ensuring that the elevator operates seamlessly. They monitor various aspects of the elevator's operation. From the speed and position of the car to the weight it carries, sensors provide real-time information that is vital for safe operation. Door sensors detect the presence of people or objects in the doorway. These sensors are designed to be highly sensitive and accurate, ensuring that the doors do not close on anyone or anything. They prevent the doors from closing if something is in the way. This is a critical safety feature that helps prevent accidents and injuries. Position sensors track the car's location in the shaft. These sensors ensure that the elevator stops precisely at each floor, providing a smooth and accurate ride for passengers. This information is relayed to the control system to ensure accurate stopping at floors. The control system uses this data to make real-time adjustments, ensuring that the elevator operates efficiently. Weight sensors monitor the load in the car. These sensors are crucial for maintaining the balance and stability of the elevator, especially in high-rise buildings where the load can vary significantly. They prevent overloading, which could strain the system. Overloading can lead to mechanical failures and pose serious safety risks, so these sensors are essential for preventing such scenarios. All these sensors work together to ensure a safe and efficient ride. By constantly monitoring and adjusting the elevator's operation, they help create a reliable and comfortable experience for all passengers. Section 8. Elisha Otis, the father of safe elevators. The invention of the safety elevator is credited to Elisha Otis. In 1852, he demonstrated his invention at the World's Fair in New York City. Otis's safety elevator featured a safety brake. It would engage if the hoisting cable broke. This revolutionary invention increased public confidence in elevators. Before Otis's invention, elevators were considered dangerous. People were hesitant to use them. Otis's safety brake changed everything. His invention paved the way for the widespread adoption of elevators. This had a profound impact on architecture and urban planning. Section 9. The Skyscraper Revolution. The invention of the safety elevator made skyscrapers possible. Buildings could now be built taller without the limitations of stairs. Cities like New York and Chicago experienced a building boom. Skyscrapers began to dominate the skylines. Land became more valuable as buildings grew taller. Elevators transported people and goods vertically. This allowed for more efficient use of space. Cities could accommodate larger populations. The skyscraper revolution transformed urban landscapes. It ushered in a new era of architecture and urban design. Section 10. Modern marvels elevators today. Today's elevators are incredibly sophisticated. They are faster, smoother, and more efficient than ever before. Computerized control systems manage elevator traffic. Destination dispatch systems group passengers traveling to nearby floors. Double-decker elevators transport more people with fewer trips. Regenerative braking systems capture energy during braking and feed it back into the building's electrical grid. Innovations in elevator technology continue to push the boundaries of what's possible. The future of vertical transportation is full of exciting possibilities. Section 11. Conclusion. The future is up. As we look towards the horizon, it's clear that the future of our cities is reaching new heights, quite literally. Elevators have played a pivotal role in shaping our cities. From the early days of urban development, these mechanical marvels have enabled us to build upwards, transforming the skyline and the way we live and work. They are an essential part of modern life. Whether it's in a bustling office building or a crowded shopping mall, elevators are the silent workhorses that keep our daily routines running smoothly. From skyscrapers to shopping malls, we rely on elevators every day. They save us time, provide convenience, and make vertical travel effortless, allowing us to navigate the urban jungle with ease. As technology continues to advance, we can expect even more innovative elevator designs. Higher speeds, greater efficiency, and enhanced safety features are just the beginning. Imagine elevators that can travel horizontally as well as vertically, or those that use renewable energy sources to operate. And enhanced safety features are just the beginning. Engineers and designers are constantly pushing the boundaries to create elevators that are not only faster and more efficient, but also safer and more reliable. The next generation of elevators will continue to shape the urban landscape. Urban planners and architects are envisioning cities where elevators are integral to the infrastructure, seamlessly connecting different levels of the urban environment. They will allow us to build taller, smarter, and more sustainable cities. With the integration of green technologies and smart systems, future elevators will contribute to the creation of eco-friendly skyscrapers and intelligent urban spaces. So, the next time you step into an elevator, take a moment to appreciate the engineering marvel that is quietly transporting you up and down. It's not just a means of getting from one floor to another. It's a symbol of human ingenuity and our relentless pursuit of progress. The future is indeed up and elevators are taking us there.